Hello everyone, today let's solve the problem carrot cakes, right? So this was asked in Playrix Codescapes Cup. Basically it's Codeforces round 413 rated for the division 1 and division 2. Right, so just give me a second. You can just go through the question. It's easier to understand. I'll just summarize so that it will be easier for us to solve the problem, right? So first, what the question states here: a guy named RKD needs n carrot cakes. See here, a guy named RKD needs n carrot cakes. 101 bakes, 101 bakes how many cakes? K cakes, right? 101 bakes K cakes every 10 minutes. Every 10 minutes. It bakes all at once. Just remember this one, right? He can optionally build a second identical oven, taking D minutes to finish. He can identically build. He can optionally build second identical oven, taking D minutes. Taking D minutes to finish, basically. While building, only the first oven runs. While building, throughout the building process, during that time, only the first oven runs. So that's what they have given in the question. So we have to decide if building the second oven strictly decreases the minimum time to reach n cakes. That's what we need to do. If it is, then we have to print yes. If otherwise, we have to print no, right? So what we need to determine here, we have to decide if building the second oven, right? So this one, if building the second oven strictly decreases the minimum time to reach n, strictly decreases the minimum time to reach n, basically, right? So if it does, then we have to print yes. If it doesn't, then we have to print no, right? If it does, we have to print yes, else we have to print no, right? So that's what they have given in the question, right? So I'll just read out the question loud. Listen to this again. So a guy named RKD needs n carrot cakes, right? So 101 bakes K cakes every 10 minutes all at once. 101 bakes K cakes every 10 minutes all at once. He can optionally build a second identical oven, taking D minutes to finish, right? He can optionally build a second identical oven, taking D minutes to finish. While building, only the first oven runs, right? So this sentence is important. While building, only the first oven runs. What we need to do, we have to decide if building the second oven strictly decreases the minimum time to reach n cakes, basically. We have to print if it does, if we have to print no if it doesn't, right? So that's what the question states here. Simple one, right? So see here, we have been given 8645. Here it is possible, right? So it decreases the minimum time to reach n cakes, basically, right? So building the second oven strictly decreases the minimum time to reach n, basically, right? So in this case, we have to print s. Same goes with the example 2, 3, 4 as well. Here it is not possible, so it doesn't decrease. So we have to print no. Same goes with example 3. Here again it is possible, so we have to print s here in this case. Right? So this is the question and the input output part. So let's do one thing now. Let's quickly discuss the approach followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach. So here I have considered the same first example for the approach. So we have 8645 here. The output that we need to get here as yes. So we'll be making use of the dynamic programming to solve this particular problem. Just remember this. So let's move on with the step-by-step explanation. We have considered the same this one, same example, right? Same input, basically, to discuss the approach. Just remember this. So first, what we'll do, we have to compute how long one oven alone needs one oven alone needs this one, right? So we will calculate batches equals ceil of n by k here. That is equivalent to basically ceil of 8 by 4, right? So this one 8, total we have here as 4, right? So this one will be ceil of 8 by 4, right? So we will compute how long one oven alone needs. So the first one divided by how many number of ovens that they have given here, 4. So this will be basically 8 by 4. So the output that we got here is 2, right? So batches is equivalent to the 1 oven time, nothing but here in this case it will be 2 into 6. The next element we have this one, next one we have here as 2 into 6. What we will do, batches equals 1/1 time, so this will be equivalent to 2 into 6, that is equivalent to 12 minutes, that is equivalent to 12 minutes, right? Let's simulate the time from 1 to 1/1 time with a DP array. So for that, as I have said, we'll be making use of the dynamic programming, so we will be going with a DP of time that is equivalent to the total cakes ready by this particular minute, right? So let's move on with the next step. So the first oven finishes a batch T, 2T, 3T. Here this is 6 and 12. So here we got for the this one 6 and 12. How we got here 12 minutes, right? So here we got 6 and 12 basically, and the second O1, if built at D, it will finish its first batch at D plus T, D plus 2T, so on, right? So D plus 3T, so on. Here it will be 5 plus 6, that will be equivalent to the 11. Just remember this one, right? So this is fine. Finally, let's move on with the timeline. Timeline here at the minute 6, first one produces 4 cakes, nothing but dp of 6 is equivalent to the 4. We know this one, right? Previously we have discussed. So at the minute 11, second one produces 4 more, meaning 4 here at the minute 6, first one produces 4 cakes. At the minute 11, second one produces 4 more. So dp of 11 we have been given 8. 4 plus 4 will lead to 8 basically, right? 8 cakes by the minute 11, which is less than 12, which is less than 12. So here building helps. Less than 12, why? Accordingly with the question, they have asked us to decide if building the second oven strictly decreases the minimum time to reach n cakes. So basically we got 12 here, so we have to check whether building the second cake or second oven strictly decreases the minimum time to reach the n cakes. So yeah, it has decreased from 12 to 8 basically. 8 is less than this one, right? 8 is less than 12 basically by the 11th minute basically, right? 11 we have got it from here, right? 11 we have got it from here. So 8 cakes this one 8 cakes by minute 11, which is basically less than 12. So building helps here. Building helps here means building the second oven helps here basically, right? It decreases the minimum time to reach the n cake, so it helps here. In that case, when building the second oven helps, then we have to give s, right? Accordingly with the question they have mentioned, right? So here we will be giving s, right? If building doesn't help, if it was greater than 12, then we had to give no. In our case, building helps basically, right? So we'll be giving s here. So the output that we got here is s, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct in this case. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be because of 1/1 time, which is equivalent to, so this is almost equivalent to BICO of this one, seal of n by k. So here in the approach we discussed, right? So it will be because of seal of a math, basically we'll be making use of math.seal, right? So that comes from the math package. So this one into t, because we are simulating every minute up to the time 1/1 needs, the first one or the 1/1 needs basically, right? So overall time complexity is equivalent to because of seal of n by k into t. So basically we can give here because of 1/1 time in simple terms, right? So what will be the space complexity? Space complexity would lead to because of 1/1 time as well, as we'll be making use of the dp array of size 1/1 time plus 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be because of 1/1 time and because of 1/1 time respectively. Now as we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code. So let's start writing the, I'll just come here. We'll be making use of the fast input output and the utilities, right? Different utilities. So I'll just import here input output package. This is fine. Also let's import here utility package as well. This is fine. So let's go with a class named main as usual, right? So you can just give any class name that's relevant to the question. So I'll just give main here as usual. So let me make use of the main method. Let me remove this one also. Let's include throws this one, right? Input output exception, or else we'll be getting the error. This is fine. The next step would be, let's go with the input output part here. So this one will be buffered reader br equals new buffered reader new input stream reader. So this one will be system dot n, right? So next it will be print writer. So this one will be print writer equals new print writer. So this one will be system dot out. This is fine. The next step would be, we have to read the single input line and split into tokens, right? So I'll just give here string, we consider variable s buffered reader dot read line. We have to split as well, right? Split into tokens. Basically we have space within this one. In the input we have to consider, basically we have to read number of cakes needed, minutes per batch per oven, also cakes produced per batch, and also minutes to build the second oven. This one I'm speaking of 4 things that they have given here, right? 8645 8646, this one, right? So we have to read them basically in the form of input. So this one all of the type integer basically, right? So this one will be integer dot %. So this is fine. I'll just give here string s of 0, right? So this is nothing but for the number of cakes. For other things also we have to do the same thing, right? So all of the type integers itself. So let me copy this one and make the necessary changes. So this one 4 we have. So this one would be n t. So this one will be k, and also this one will be d, right? So this is fine, man. Integer % of this one will be 1, this one will be 2, this one will be 3. This is fine. Now we have went for the number of cakes that is needed, minutes per batch per oven, cakes produced per batch, and minutes to build the second oven. This is fine. So the next step would be, we will be going with a 1 oval total time. So I'll just go with int 1 o1 this one time. Let me assign this one to the n plus k minus 1. This is fine, by k into t. This is fine, man. The next step would be, as I have said, we'll be making use of the dynamic programming to solve this problem, right? So first, before initializing the DP array, let me assign the max time to the 101 time, right? So this is fine. Also let's initialize the DP array. So I'll just go with DP equals new one of size max time plus 1. So this is fine. Let me make here this one capital T. Also here let me go with capital T here, right? So this is fine, man. Next, let's do one thing. Let's move on with the iteration part, because we have to simulate each minute from 1 to max time, right? Accordingly with the approach, if you remember. So this one will be int. So this one I'll just go with time equals 1, time less than or equal to max time. So this is also fine. And this one time plus. So this one will be dp of time, that is equivalent to dp of time minus 1. So this is fine. Just give me a second, 1 second here. The next step would be, if the first O1 finishes a batch at multiples of t, then we have to add k cakes, right? So I'll just go with if time modulo t that is equal to 0, then what we need to do, so I'll just give here dp of time. Let me assign this one to dp of time plus k. So this is fine, man. How can I write here this one k? This is fine. So the next step would be, let's go with a one more if condition, because if we build the second O1 that finishes at time d plus m into t. If suppose if we build, then it has to finish at the time d plus m into t, because m will always be greater than or equivalent to 1. Let's write the same this one, a similar thing, if condition, right? Again, so this one, if time greater than d and if time, So let me write this one within the parenthesis, because if time minus d, we have to go with the modulo t, right? So if it is equivalent to 0, then dp of time, I'll assign this one to the dp of time plus k. Sorry, why did I write this one within the, so it will be dp of time equals same thing. I press insert here. dp of time equals dp of time plus k. So next, if by this minute we already have at least this one n cakes, then we have achieved this one strictly before 101 time, then we have to print s, else we have to print no, right? So let's write the simple if condition again. So if dp of time, if it is greater than or equal to n, meaning if by this minute we already have at least n cakes, right? So then if it is achieved, then we have before this one 101 time, then we have to print as, else we have to print no, right? So I'll just go with out dot println, because we have made use of the this one print writer. So this one, if time less than 101 time, then we have to print s accordingly with what we have discussed, else we have to print no. This is fine. Yep. Now let's do one thing. So we have to ensure output is written immediately, man. So this one will be out dot flush. This is fine. We have to ensure output is written immediately. Also we have to terminate the program. We already decided this one, right? So let me return this one, right? So this is fine. Yep. We are done with this part. Basically, if loop finishes without printing, meaning it means dp never reached n before at 101 time, right? So also the original code, whatever we have written, so this returns inside this one, inside loop, when dp is greater than or equal to n, and also we are simulating only up to 101 time, right? So we know this one, right? And one more thing, so we don't have to go with the extra print right here. This is not necessary here. Just we can just keep the original behavior, right? So I'll just we have just exited here by making use of the return. We don't have to print anything here, right? So this is it for the code. So let's do one thing. Before checking the code with the different inputs or the examples, so let me copy paste the signature starter template. Just so I'll just come here. Sorry, let me do one thing. Let me paste it over here. I'll just come to the question here. So input, let me copy this one. The output that we need to get here is let's check what output that we get here. We are getting the wrong this one, right? So this one has to be system dot out. I have given comma here. So this is the only error, I guess. We have one more. Oh, this has to be time. I have misspelled here. Line number 39. Yep. Let me remove this one. Let me run. Yeah, we are getting the output is right. So this one we have to get no. So the output is no here, and the third one here we have to get no again. Let's check. So this one is no. The final one here we have to get is here. Let's check the same one. Let's see. Yes, we have got the output s here. This is fine. So let me do one thing. Let me copy this one entirely. Let me come here. Let me hit the submit code button. Let's wait for some time. Yeah, let me paste the code over here and let me hit the submit button. I hope this works for all the. This is running. Let's wait for some time. See here, running on test 92. Yeah, and the toast it is showing accepted. The verdict that we got here is accepted as well. So whatever the code that we have written works absolutely correct, right? So see here, we have made use of the pure DP to solve this particular problem, right? So the code works absolutely correct, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.